To find the center of mass of a regularly shaped object, like this block of wood, it's nice and rectangular, uniform density, same thickness throughout. The center of mass of an object like this is at its geometric center. So for this, I can just take my ruler, I can draw a diagonal from one corner to the other, and draw another diagonal from the other corner. And where the two lines intersect, that's going to be my center of gravity of this object. What I'll do is, I'll just take a nail and I'll insert it into the center of gravity. Now I'm going to take this string that has a weight on it. This is called a plumb bob. Anything I hang it from, this will hang straight down, of course, because of gravity, and that'll show me the direction of down. And now I can see the point about which the center of gravity is directly over, right above that yellow piece of string. If I take the block and tip it, as long as the center of mass stays on this side of the support point, right here is where the block is touching the table, as long as the center of mass is on this side of the support point, the block is going to continue to fall to that side. I'll keep tipping it until you'll notice that as soon as the string passes onto the other side of the support point, that's when the block will tip over. The next object that we'll find the center of mass of is an irregularly shaped block. You'll see I've cut a corner out of this one, so it's no longer a nicely shaped rectangle. Now what I've done is I've hammered a nail into it so that I can support the block by the nail. I know that the center of mass will always hang below the point of support. If I make it so that the center of mass is not below the point of support, when I release it, it swings back so that the center of mass is always below the point of support. So what I'll do is, I'll take my plumb bob, I'll hang it from the nail, and now I know that my center of mass is somewhere along that line. So I'll draw a point where the string is. And then I'll connect that point with my ruler. So now I know the center of mass is somewhere on that line. Now I've moved the nail to another spot on the board. Again, I'll put my plumb bob on the nail. I'll hang the board from the nail, and I know that my center of gravity is somewhere on that vertical line. So I'll draw another dot where the line is. I'll connect the space between the nail and the dot with my ruler. And now I know where the lines intersect. That's going to be my center of gravity. And to check that out, I should be able to balance the object at the center of gravity. And in fact, that is where it is. The object should spin well about the center of gravity. So what I've done is, I've driven a nail right into the center of gravity, and even though this is a very irregularly shaped object, since I know this is the center of gravity, it should spin very nicely about that point. Let's try the toppling experiment with the irregularly shaped block. I'll hang my plumb bob, and I know that the center of gravity now is above a point of support, and the block is stable. If I put it this way, again, the center of gravity is above a point of support, and the block is stable. However, if I put the block this way, you notice that the yellow string is just a tiny bit to the left of the last point of support right here. So that creates a small lever arm distance which produces a torque, and the block tips over. Here's an interesting object. It's just a piece of wood with a hole in it, and it's beveled to be flat on both ends at an angle. And I can take my bottle, put it through there, and it balances. What does this tell me about the center of mass, or the center of gravity, of this system? Well, I know that the center of mass of the wood and the bottle together must be directly, vertically above this point of support. Otherwise, it would tip over. Here's another one. This little bird, I can balance it right on his beak. So I know the center of gravity of that bird is somewhere on the line, directly, vertically in line with the point of support. In this case, it's most likely below, like the block that I hung from the nail. Here I've got a broom, and I'll put it on my hand, and I can balance the broom. I can feel which way the broom is going to tip, and I can adjust my hand to keep it underneath the center of mass of the broom. And as soon as I stop doing that, the broom tips over. This is similar to the way a rocket fires. As the rocket launches, sensors in the rocket detect if it's tipping side to side, and small rockets fire on the side to keep the center of gravity of the rocket over the thrusting force and keeps the rocket straight as it rises through the air. Another vocabulary word that we'll look at is the word stability. For something to balance, of course, like we mentioned, the center of gravity of the object has to be above the base. Not only this way, but also this way. And the higher up the center of gravity is, the less stable the object is. Okay? I'll still balance it on a thin edge, but I won't make it so high. Now I can tap it. You'll see it wobbles a little bit, but it doesn't tip over. Compared to this, just the slightest touch, and it tips over. Of course, if I put it this way, that's going to be the most stable of all. The center of gravity is very low, and the base is very large, and I can't tip that over. Here I've got two plastic cups. The first cup is just a cup by itself. The second cup has a ping pong ball glued into the bottom of the cup. What I'll do is, I've marked a black line on each cup, and I'm going to take some water and I'm going to fill each cup up to the same level. So each cup will have the same level of water in it. Then I'll tip the platform and we'll see which cup tips over first. Which cup do you think will tip over first? Okay, so let's fill the cups with water up to the black line so that both cups have the same level of water. Now ask yourself, which cup has the higher center of gravity? And remember, the higher center of gravity means less stability. So as I tip the board, and we see that the cup with the ping pong ball in the bottom had the higher center of gravity. Because down here where the ping pong ball is, that space is filled with air. So more of the mass is higher up than in this cup.